Hi, today we're going to be going over linear equations in R3. I'm Neil Forsythe,
And I'm Davey Holmes.
and the best way to start this would just to be a quick review of lines in R2. So to start off, our equation, y is equal to mx plus b, gives us a line in R2, with m being our slope and b giving us our y-intercept. So if we plot this real quickly, we have y-intercept and a line, x and y. So, things get a little bit trickier when we start to transition from R2 to R3. Because our slope is no longer going to be represented as a single value, but instead as a vector. And here's the reason why. So say, for instance, we have a plot of, in R3, with, hold on, we have a plot with this being y, x, and z. If we plot the same line in R3, we get a line that looks something like this. But if you notice from this equation, z is going to be defined at every point along this line. And what we actually end up getting is, we end up getting a plane, because since it's defined at every time, R3 this equation just gives us a plane in R3. So the only way we can really work on bypassing this is to use vectors instead of as our slope, instead of using this equation here. And to quickly introduce the topic, so as we just reviewed, the equation for slope, which is delta y over delta x, our m value in this equation just gives us a plane. So the best way to plot a line in R3 is use of vector notation. And to quickly overview this, our vector is going to be, for instance, change in x, change in y, and then depending on how many components, or what, and depending if we're in R3 or R to the n, we're going to have this basic equation that will give us our change in x, change in y, and change in every component, and allow us to be able to graph a vector that gives us a slope, at certain points in our line, no matter what the dimension is, instead of just getting a plane as we previously saw.
Good?
Yeah.
Alright, so as Neil just showed us, a slope in Rn will be shown by the vector v, which is delta x, delta y, change in any other variable you have, delta n. Okay? And so what this vector shows us is, if you multiply it by t, you're going to get, we're going to change the name here, we're going to say r of t, and multiply each one of these by t. So r of t will be equal to v times t, r of t will equal delta x times t, delta y times t, and then delta n times t. So what this will do for us is, it kind of works as a pencil. So if we start here at point, let's say 0, 0, as many zeros as you have variables, then let's say r of 0 gives you the vector, this first vector, r of 1 gives you the second vector, r of 2 gives you the third vector, and so on. Now, as you can see, it kind of looks linear, right? So the vectors work as a pencil to trace out our line, which we can call L. Let's erase this real quick. And make some more space. Alright, so I'm going to show you an example of how this pencil vector works in R2. So in R2, we have our line y equals mx plus b, and so what we get is we start at point 0, 0, and we get first, when we have y equals mx plus b, this r of 0, which is going to equal b, and then we can go r of 1, which will equal mx plus b. So the actual equation would be r of t is equal to x mx times t, the change in x, change in y, times t, but then we also have to add a point on the line to get it to shift up. So we're going to add the y-intercept here, point 0b. So plus 0b. Okay, that's the general equation. Now if we transfer this to R3, it's kind of going to do the same thing. Let's just pick a random line here. Right there. We have, let's see, this is z, y, x, and line L. So we're going to start from the 0 point and take, I don't know, let's say R0 goes there, R1, and R2. Okay? So that's the general image. Now, how are we going to transfer the equation to R3? It's pretty easy. We already discussed it a little bit. So in R3, r of t will equal the vector delta x, delta y, delta z times t, but then we have to add another point on the line, so that point we're just going to call x1, y1, and z1. Okay? And this is your general equation for a line in R3. Thank you.